Hi there, and welcome to this lesson on Further Pure Mathematics 2. And in this lesson, we'll be looking at series expansions of compound functions. Now, first of all, we talked about the formula book in the last lesson. And if you're taking the International A-level, then the formula book does have all of the formulas you need in it, plus the conditions for validity. So it gives you the series for e to the x, which is valid for all values of x, sin x, which is also valid for all x, cos x, which is valid for all x. It gives you the series we were looking at in the last lesson, the log of 1 plus x, which is only valid between -1 and +1. And it gives you the series for arctan x, which is valid between -1 and +1. If you're doing a question, do just be careful on whether you have strict criteria here or not when you're looking at the validity. And the other series it gives you is extremely important and frequently turns up in questions. It's the binomial expansion, so the expansion of 1 plus x to the n. Now, the conditions for validity are a little bit confusing with this because there's two different sets of validity that you need to be aware of. First of all, the binomial expansion is valid for all powers, so for any value of n, as long as x is between -1 and +1. And then it is also valid for all values of x, as long as the power is a positive integer. But do walk carefully with that. So it is valid for any power, as long as x is between -1 and +1. It is valid for any value of x, as long as n is a positive integer. And in questions, frequently, rather than having x, you'll have some function of x, which means that in these series expansions, instead of writing x, you will have to write whatever the appropriate function of x is instead. Okay, let's have a look at how this works out in practice. So that's the series expansion for sin x. Find the first three terms of the series expansion of x times by sin x squared, and state the values of x for which the series is valid. Well, x is just x, and then we'll be multiplying that by the series expansion when we substitute in x equals x squared. Now, it never feels very clever with substitutions when you substitute one letter with the same letter, but it frequently happens in these questions. So instead of writing x, we'll be writing x squared. Okay, I'll let you have a go at this. Pause the video and then come back to me again when you're ready. Okay, let's have a look. So x sin x squared, and as we said, we write down this series expansion for sin x, but substituting in x equals x squared, and that will give us that. And multiplying out the brackets will give us that. Now, this is valid for all x squared that are a real number, which means it's valid for all x that are a real number. Okay, example 2. Find the first three terms of the series expansion of 1 over 1 plus 2x to the third, and state the values of x for which the series is valid. Now, this is the binomial expansion. First thing we'll need to do is rewrite this as 1 plus 2x to the minus a third, and then press on from there. I'll let you have a go at doing that. Pause the video. Come back to me when you're ready. Okay, let's have a look. So as we said, first thing you need to do is write it as 1 plus 2x to the minus a third, and then n is equal to minus a third, and we're substituting in x equals 2x into the series. That will give us that. If I tidy that up, it gives me 1 minus 2/3 x plus 8 over 9 x squared. And in terms of validity, well, I've been doing this expansion, so I've got 2x, which means it's valid if 2x is between -1 and +1, which means it's valid if x is between -1/2 and +1/2. Do be careful on what you put in here. Example 3 is quite a lot more difficult. We're asked to find the first 4 terms of the series expansion of e to the power of sin x. Now, I'll give you some hints in terms of how to get started because neither of these things are obvious. But first of all, we'll actually only need to use the first 2 terms of the expansion of sin x to do this question. And secondly, when we do e to the sin x, there are a couple of ways of thinking about it, but the right way for this question is to substitute in for sin x first of all, and just substitute in the first 2 terms. That is all we'll need. Okay, I'll let you have a go at following the rest of this question through. So pause the video, have a go, and come back to me again when you're ready. Okay, let's have a look. Well, these two terms we can split up using the law for powers. So that gives us e to the x times by e to the minus x cubed over 6. And then we can substitute each of these into the series for e to the x. So the first one just is e to the x. And then the second one, we have to substitute in x equals minus x cubed over 6. And that will give us this. Now, it's not immediately obvious how many terms you're going to need in each bracket, but this will be sufficient for this question. Tidying that up would give us this. Okay, what we have now is an infinite series in the first bracket, and we also have an infinite series in the second bracket. And we need to multiply together those two infinite series, which feels like it might be problematic, but it isn't, because we're only interested in the first few terms. Now, the first term will be any term which just has a constant and nothing else. So what you look for is a term in the first bracket multiplied by a term in the second bracket, which would just give you a constant. And that only happens in one way. If we have 1 in the first bracket times by 1 in the second bracket, that gives me a constant. So that's the only way I can get a constant. I don't need to worry about anything else for constants. Now we move on to x's. Now, to get an x term, if I have 1 from the second bracket times by the x in the first bracket, that'll give me a term in x. But that's it. There is no other way to get a term in x. So I'll have 1 plus x. Now we worry about the x squared terms and how I could get those. Well, if I do 1 in the second bracket times by the x squared over 2 in the first bracket, that'll give me a term in x squared. But again, that's the only way I can get one. So I'll have plus x squared over 2. Moving on to the x cubes, things finally become a little bit more complicated because there are two ways of getting x cubed terms. I could have 1 in the second bracket times by the plus x cubed over 6 here, or I could have 1 in the first bracket times by the minus x cubed over 6 in the second bracket. But that's it. There are no other ways of getting a term in x cubed, but these two terms will cancel each other out. One of them is going to be plus x cubed over 6, the other one's going to be minus x cubed over 6, which means there won't be a term in x cubed. Now, I've been asked to find the first 4 terms. So the first 3 will be those 3. There won't be a term in x cubed, but I do need to find the term in x to the 4, which is why it now becomes clear that I only did need one more term in this bracket, the x to the 4 term, and I certainly don't need anything more than x to the 6 in the second bracket. So looking at the x to the 4 term, there are two ways of getting it. I could have 1 times by the x to the 4 over 24 here, or I could have x from the first bracket times by the minus x cubed over 6 in the second bracket. Both of those will give me terms in x to the 4, plus x to the 4 over 24 and minus x to the 4 over 6. So tidying all of that up, the terms in x cubed cancel, and the terms in x to the 4 simplify to this. So the first 4 terms of the series expansion of e to the sine x are 1 plus x squared over 2 minus x to the power of 4 over 8. Okay, example 4. Given that f of x is equal to a into 1 plus 2x to the half minus the log of 1 plus 3x, where a is a constant, we're told that the series expansion of this function has no term in x. Using that information, we're asked to work out what a must be. We're then asked to work out the first 2 terms in the expansion and then write down the range of values for which the series expansion is valid. Okay, I'll let you have a go at working your way through this. So pause the video, have a go, and then come back to me again when you're ready. Okay, let's have a look. First of all, we're asked to find a. Well, we're going to have to find the expansions for these 2 functions. A into 1 plus 2x to the half, that's the binomial expansion. So that will give me this when I substitute in x is equal to 2x. And that simplifies into a into 1 plus x minus a half x squared. And that'll be enough terms. The log of 1 plus 3x means I need to substitute in x equals 3x into the top series there, and that will give me this, which simplifies to 3x minus 9 over 2 times by x squared. And again, for what I'm doing at the moment, I won't need any more terms in that. The only thing I'm really interested in at the moment is the term in x, and exactly why there is no term in x. Now, if I do the first thing, take away the second thing, which is what this function is, that will give me that. And that simplifies to a first term, a constant term of a. The term in x is a minus 3 times x, and the term in x squared is 9 minus a over 2 times by x squared. Now, that's what I just did. Coming to what the question tells us, which is that there is no term in x. Well, if there's no term in x, that means that a minus 3 must be equal to 0. And then I'll have 0x. And that means that a must equal 3. That's part 1 done. Part 2 asks us to find the first 2 terms in the expansion. Well, we can do that now because we've worked out that a equals 3. So substituting in a equals 3, the first 2 terms, well, the first term will just be 3. The term in x vanishes. So the second term will be this one, the 9 minus 3 over 2 times by x squared. And that simplifies to 3 plus 3x squared. And then part 3 asks us to state what range of values for which the series expansion is valid. Well, we've got 2 series on the go here, and we do need to consider both of them. So the series expansion is valid. First of all, looking at the binomial expansion, it's valid if 2x is between minus 1 and plus 1. And then looking at the expansion for the log of 1 plus 3x, it's valid if 3x is between minus 1 and plus 1. Simplifying both of those, that means it's valid if x is between minus a half and plus a half. It's valid if x is between minus a third and plus a third. Now, when we combine series, what we have to do is take the most strict of the restrictions, because the most strict restriction will work for both. And in this case, the most strict of the restrictions is between minus a third and plus a third. So the series is valid if x is bigger than minus a third and less than or equal to plus a third. Okay, that gets us to the end of this lesson. If you've got the book, then turn to page 134 and have a go at exercise 7C. Thank you very much for listening, and cheerio.